Hello and welcome. Mr. Lyons here, back at it again with another what? Another banger. You already know the vibes. And we're writing things in scientific notation and standard notation. But in this specific section, right, we just did transferring scientific notation into standard notation, right? But in this specific section, we are turning standard notation into scientific notation. And let's just remind ourselves what that word means. Scientific notation, right? Flip back the page. There are two components. You multiply two things, and that's how you see scientific notation, right? We're multiplying what? What are we multiplying here? Well, we have something called a leading, that's right, factor. Pause the video if you need to go back and review. All right, the leading factor multiplied by a power, don't know why my ink isn't working, of 10 here. That's right. So we have a leading factor and a power of 10. But something very specific about the leading factor, it has to be in between 1 and 10, right? It can't be bigger than 10, can't be less than 1. So let's talk about this here. What number is this? This says 3 million. How many times was 3 million multiplied by 10? Express 3 million in scientific notation. So we know in scientific notation we need a leading factor between 1 and 10, and we need to multiply that by a power of 10. Would you agree? Let me change to blue because my black isn't working right now. Would you agree that 3 million, be very cautious, be very neat, is the same thing as 3 million times what? What would you have to multiply by 3 million to get 3 million? That's right, 1. But we don't want this. This leading factor here is way greater than 10, and this is not a power of 10. So let me show you how you do this. Where's the decimal in 3 million? Where's the decimal? Where's the decimal? Right here, right? So let's take away a couple place values, 1, 2, 3. We had 3 place values here, but they're not just going to disappear. They're going to go to our power of 10. So we took away 1, 2, 3, so that's going to be 10 to the third. We're moving these place values to our power of 10. Now we have a power of 10. What's my new leading factor going to be here? It's going to be 3,000. Is this scientific notation? No, why not? We have our power of 10, but our what? Our leading factor is not between 1 and 10. So how many more place values do you think I'm going to take? And what do you think this is going to turn into in scientific notation? Think? Yeah, our decimal's here now, and we can do 1, 2, 3. 3, if my decimal's right here, 3 is a leading factor. 3 is in the middle. In between 1 and 10. And this is no longer 10 to the third. We took away 3 here, 3 here. Now it's going to be 10 to the 6th. That's absolutely correct. Plug that in your calculator. See if you get the same thing. Plug it in. I'm not lying to you. I ain't going to lie to you. 3 times 10 to the... Why? Times 10 to the 6th power. Bruh. Mr. Lyons ain't here to lie, all right? And how did we do that? We sort of traded, that's a better word. We traded place values in our leading factor, and we moved it to the power of 10. So we got a leading factor in between 1 and 10, and we got our power of 10 here, right? Pretty neat. So our answer is going to be 3 times 10 to the 6th power. Pause. Now take a look here, right? Take a look at this number. Read this number to yourself. This is thousands, millions, billion. Do y'all know how much a billion is? A billion is quite a bit, right? I'm going to try to include a video just so y'all can see the types of numbers we're dealing with. And this is why scientific notation is so important. 9 billion, 40 million is a lot. What would you do with $9 billion? So we're going to turn this into scientific notation. But right now, this is 9 billion, 40 million times 1. Right? You don't have to write that times 1 there, but that's how I like to think about it. We need a leading factor in between 1 and 10, right? Remember that? Scientific notation, that's what it consists of. So where's my decimal here? Right here, that's right. I'm going to move this over 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7. I think I counted that correctly. 1, 2, 3, 4, 5, 6, 7. Beautiful. So this is going to be times 10 to the 7th, right? We're trading, right? And this is going to be what? Now that my decimal is right here, That's going to be what? 904, right? Is that what I want? Is that what I'm looking for? Not quite. Why not? I have a power of 10. However, this is not in between 1 and 10, so I have to move it over 1, 2 more times. Now I have 9.04 times 10 to the, that's 9 spaces. That's 9 place values that I moved. So I know my leading factor is 9.04, right? And I got my power of 10, which is going to be 10 to the 9th power. So this is my answer here, right? The reason why we gave you this box right here is so that you can see, like, all right, where do I want my power of 10 to be? Take a look at example 4. Let's not go down here. Take a look at example 4. One of the first things you want to notice is my power of 10 going to be positive or negative? We use positive exponents of powers of 10 to show really large numbers. And we use negative exponents to show itty bitty numbers, right? That's why we had a positive 9 here, positive 6 here. Is this a really big number or a really small number? It's a really small number. So before I do anything else, I can put times 10 to the something, a negative power. Look at your vocabulary and think, why did Mr. Lyons put a negative number there? I put a negative number there because it's going to be a really small number here. So let's think, how am I going to get my leading factor? Well, I'm going to have to move this decimal not to the left this time, but to the right. 1, 2, 3. 3.05 is in between 1 and 10. 1, 2, 3. All right, times something. All right, we have our leading factor here. This is in between 1 and 10. What is going to be my power here? And how do you know? Is it going to be, well, we moved it 1, 2, that's 3 times, right? Is this correct? No, this is showing a big number. Because our number is less than 1, it's actually going to be negative 3. That's why we always put that negative sign there. We determine, is our exponent going to be negative or positive? Big number or small number, right? Beautiful. Let's go ahead and take a look at example number 2 now. Should my exponent be positive or should my exponent be negative here, and why? Well, this is a relatively big number, so I know my exponent's going to have to be positive something. Where's my decimal? Where's my decimal here? My decimal's right here. I need to trade place values because I need my leading factor in between 1 and 10, so I'm going to move this 1, 2, 3, 4, 5, 6, 7. Is that enough? Is that enough right here? No. 8. You move it 8 times because 5.67 is in between 1 and 10, right? That's going to be 5.67 times 10 to the what? How many times did we move our decimal? How many place values did we move? Did we trade? That's 8. 5.67 times 10 to the positive 8th power, right? Really big number. See if you can do these on your own. See if you can do these on your own, the rest of these, okay? I'm going to help you write this one out for example 3. 46 million, you should know how to write that out. Right? Thousands, millions, right? I'm going to do this last example all together, and then you're going to try these last 2 examples on your own. Feel free to pause the video if you want to do example 5 on your own as well. And you're going to try these on your own after I model this one. So I know this is a very, very small number, right? It's less than 1. So I know my exponent is going to be negative, but I need a leading factor in between 1 and 10. So I'm going to move my decimal over 1, 2, 3, 4 times. Be 9.2 times 10 to the negative 4th power. My leading factor was 9.2 times 10 to the negative 4th power right there, right? There's a really small number here, right? Go ahead and try these on your own. There's going to be a key on the next slide just to make sure you got these correct. Make sure you use your strategy. Is it a big number? Okay, then it's a positive exponent. Is it a small number? It's going to be a negative exponent, okay? And try these on your own, and I will check you on the next slide.